NOTACON. I'm going to take some time this afternoon to talk about high availability using Linux. And now it's going to be a pretty broad presentation. It's not going to be sort of something that you can sort of use as a how-to, but certainly something that you can build on if you want to do something insane with Linux in terms of, making routers, making high availability services like email, web services, all that kind of good stuff. So that is me, David, my email address, and my website. And then there's a IRC channel that a lot of us hang out on the OFTC.net. I don't even remember what OFTC stands for. We hate openprojects.net, I don't know. But the Ohio Linux channel is where a lot of people hang out. So in general, a lot of people from this area will hang out on that IRC channel. And I know that some people here do already. Others may think about it. So that's usually a good place to get some information if you're working, even if it's completely unrelated to Linux. It's a good resource for tech people in the Northeast Ohio area. You do get people from Columbus on there and all that kind of stuff. So it's kind of an interesting group. Okay, who the hell am I? Okay, I guess I'm lots of things. I guess my primary goal in life is, I'm a network guy pretty much. I work with a lot of Cisco gear, Linux, all that kind of stuff. I maintain Unix boxes. I've been doing this for basically forever. I'm also a writer for a couple of different magazines. Probably one of the most well-known is Linux Format. That costs like $15 over here or something retarded like that. So it's, you can buy it at Micro Center. It's a really, really good magazine, if I don't say so myself. But there's that. I also run the Linux Users Group of Cleveland here downtown, and pretty good group of people. We have meetings every second Saturday of the month at Greg's office at Internet in the Superior Building, and we usually get maybe a dozen, 18 people turn up, and we just talk about. Well, we usually have some subject that we talk about, and then after the first hour, it drifts off into whatever else Larry's got going on in the world. So, I should say that Larry is a guy that works for Progressive who bought one of those $500 laptops from Walmart, and every time he comes, he has a different issue with it. I can't get my wireless to work. I can't get my mouse to work. I think he's got everything working on it now after like 6 months. I also contribute to a selection of open source projects. So I like to give back as well as take, and believe me, I have taken plenty over the years. So I don't really contribute much to NetFilter right now, but I did a couple of years ago. Still pretty involved in user mode Linux. If anybody here is involved in any lugs, I did a selection of UML presentations about 18 months ago around various places. And I've also contributed some code to the Linux kernel, specifically with relation to networking stuff. So pretty broad knowledge and all that kind of stuff. You're probably asking, okay, you're here, why should I care what you say? Basically, I've used Ethernet and IP for probably 12, 15 years. I've used it in production for 8 years, and everything I talk about today, I've got running in a data center. So it's not just stuff that's on paper, it's stuff that generates heat and buzzes. So, it's actually real world things. Probably one of the bigger accomplishments I've done that actually relates to this particular topic is there's a couple of those little websites like Slashdot.linux.com. You get maybe like 5 million hits a day. They used to run on Cisco equipment. We got all that Cisco equipment and said, this is crap. Threw it away, put in 2 Linux boxes. It works great. I also took a note that FARC, if anybody here read FARC? Anybody here noticed that FARC is broken like every other day for the last month? So I'm going to print this presentation out and give it to Drew and say, read this. I don't know what they're thinking. Let me just, so I can actually see this. 1 second. There we go. No. Okay. Now, before we get started, we should probably discuss what is high availability. Basically, what it is the ability to continue to provide network services when something breaks. And it can be something breaks on purpose, or something breaks just because it wants to. And high availability is always sort of a mixture of the planned maintenance and planned network changes that are done on a network, as well as unplanned outages due to software problems, hardware problems, misconfigurations, all that kind of stuff. So high availability in general is a way to continue whatever service you provide on your network, even when something doesn't work. Most common thing to do with high availability is the fact that we have to have a lot of the same thing. No longer you can't go out and buy 1 switch, you have to go buy 2 or 3. You can't buy 1 router, you have to go buy 2 or 3. So in terms of the actual cost of implementing HA, it's a little bit more expensive than initially than going with a simple flat network. The upside is that you'll still have customers when one of them breaks. So I always like to have a few extra spares there, and it comes in pretty handy. Another great advantage of HA is that you can go and do network changes during the day. You can take out routers to do upgrades. You can do all sorts of stuff like that, and it won't really impact much. Now, obviously, you don't want to do that day in, day out, because there is some interruption during the migration. But if you really need to upgrade something, or you really need to take something out because it's broken, then you can usually do that without causing too many problems. Another great opportunity with HA is that when something breaks, you don't have to jump on it straight away. So when the router goes down or a switch blows up, unless it's actually on fire and threatening something else, then you can just stay asleep. And then you come in the morning and fix it. Now, the goal of any network is to be up all the time, or at least up as often as it needs to be. Telco World has the 5 nines expectation, which is 99.999% of uptime, which I think works out at about 5 minutes of downtime a year. Now, anybody here who works on Cisco equipment knows that you're probably not going to get even 1 reboot in 5 minutes. Linux boxes, maybe you get 2. So if you want to get 5 nines of uptime, you've got to have another way of getting your traffic through other than just one thing. Obviously now, as things become more complex, and especially in terms of routers and switches, the whole what is a router, what is a switch, is kind of blended together. It takes much longer for something to come up once it goes down. So working around just a simple reboot is important. And obviously, once you have an unplanned outage, doesn't matter what your network is and what you're doing, without any high availability, 5 minutes, you're going to hit 5 minutes pretty quick. You're probably going to hit 5 minutes before it gets to somebody's pager. So if you really want 5 nines, then you have to use some other tools. The other great thing with HA is that it's much simpler to administrate outages. You don't operate in crisis mode. You're not chasing something. You go in and you resolve an individual issue rather than dealing with a problem and dealing with customers, your boss, whatever else at the same time. So you resolve an issue a lot more logically, and you don't always have to fight whatever's coming down from above telling you, why is this down, why is this not working, when you can fix it later. Obviously important to understand what HA is not. It isn't traffic distribution, load balancing. It isn't going to put web traffic on 2 different boxes. You can do that with it, but HA itself is not going to do that. It's not a alternative to actually setting stuff up right either. If you have HA, chances are your network configuration is going to be probably 10 times more complicated than with a flat structure. Certainly when you get into looking at IP and doing stuff like BGP, OSPF, complex routing, once you screw that up and you're pretty much done for. So while HA does give you lower administrative overhead in an outage, it increases your overhead in terms of setting stuff up properly. And with a HA network, there are some things that you have to think about in terms of, if I make a change here, how will it have a domino effect down the entire network? So you really need to have a good understanding of what you're doing. Otherwise, it's just going to come and slap you in the face later. And as always, you can have as many switches, routers, whatever you like. But if you've got SVC coming in through the wall, you're still kind of screwed. If you have one utility company for power and you don't have a generator, you're probably screwed as well. If you don't have redundant AC, especially this time of year, now it's starting to get warmer, computers like cold. So it's kind of important to have that. Now, we're talking about Linux here, but almost every single operating system has some HA capabilities, whether it's I shouldn't say operating system, platform is probably more appropriate. If it's OpenBSD, NetBSD, FreeBSD, Linux, Windows has some kind of HA capability, Cisco stuff, Foundry, all that kind of thing. Reason for using Linux, because it just works. Linux is pretty much rock solid. You get a system where lots of people have played with it, lots of people have tested it. It's not a system where you have a preset configuration that you have to abide by in order to make it work. You can pretty much do whatever you want with it. Linux also is pretty adaptive in terms of what it can do. You can have one Linux box that is a switch, a router, a load balancer, a load balanced node, a DNS server, a mail server, a web server, an FTP server. Have it handle your voice over IP and some other stuff all at once. Now, that's probably the worst thing you could possibly do. But in terms of HA, sometimes having more than one service on a single box can be pretty useful, and if you have to migrate services from a separate system. So Linux is pretty flexible that way. It's 2005 now. Linux is supported by a lot of companies: IBM, Novell, HP, all that kind of stuff. They all support Linux. So if you want to roll this out commercially, or roll it out within a corporation where something that's free doesn't have a whole lot of weight, $1 billion from Linux goes a long. $1 billion from IBM for Linux goes a long way. I also noticed some banner ads on Slashdot over the last couple of weeks saying that Linux is more expensive than Microsoft. I think that's my explanation anyway. I assume they're including the cost of training an getting a monkey, training it for the MCSE, and then teaching it how to use Linux. So I don't know, but in any case, Linux is cheap. You can get a CD. You don't really have any licensing costs. You just have the cost of the hardware, and if you have some hardware laying around that you can play with, then you're all set. I assume anybody who's used a computer for more than a week has some idea what the heck this is. This is the OSI model used for networking. It just shows a couple of different layers. I put it in here just because it looks ugly, so it seems to obviously have some bearing on things. Now, what we're going to look at today in terms of HA are these particular layers. We're going to start with Ethernet, which everybody knows and loves. Obviously, Ethernet, while I did say switches and network cards, wireless 802, 802.11b, A, G, I, N, whatever they have now, that's all Ethernet. Now, doing redundant wireless is a little more complicated. And I didn't touch on it here, but it's certainly something that can be done with Linux, especially if you have one of those Linksys things that run Linux anyway. You can do some funky stuff with that. Next layer up is obviously layer 3. That is the whole IP thing. This is, routers, basic services, and that internet thing all talks IP. It's worth bearing in mind that while most of the time layer 3 runs across layer 2 and layer 2 is Ethernet, layer 2 in terms of the internet can be a bunch of different stuff. It's not uncommon for layer 2 on the internet to be ATM, MPLS, PPP, HDLC. It can be a lot of different protocols. So we aren't going to touch on any of those layer 2 protocols other than Ethernet. We're laughing at. And then we move on to the fourth layer, which is TCP, UDP, ICMP, ports, protocols used for basic network services. Pretty much anything you're going to use on a network will be using one of those protocols. And if it's not using that, it's probably not using IP, in which case we don't care about it. So that's kind of a general overview. Any questions so far before we delve further in? I don't know if that's good or bad. I'm going to assume it's good. Okay. Ethernet, otherwise known as 802.1, or it's actually 802.1, yeah, by the IEEE. Ethernet is basically a frame-based system. It learns. It's a learning system by design. It learns where systems live in terms of a switch network. You start out with basically a blank network. You send a broadcast saying, where is this IP address? And then it learns where it is. It learns the MAC address from that. And then it learns which MAC address goes with which port. Then it knows how to send the packets and the frames and stuff. So in some senses, Ethernet has some HA capabilities built in, because you can get a network device, unplug it from one switch port, plug it in another switch port, and everything just keeps working because it relearns where it is. A couple of different things you can do with Ethernet to make it HA. This really has nothing to do with Linux right now, but it's a pretty good precursor to the other stuff. You can use multiple links between two switches, bonding, ether channel, a couple of different names for it. Basically, what it will do is it will just, do per frame load balancing over these two links. One goes down, it'll send it over the other one. So it's kind of useful if you want to do two separate paths. So say if you're going between two switches in a building, you want to take one link one way, one link another way, just in case somebody cuts through it, then you can do that. Obviously, that increases your bandwidth, but it doesn't give you a whole lot of redundancy, because if the one switch fails, you're still screwed. Ethernet itself actually has a pretty good system called spanning tree that is really nice in terms of handling lots of switches on a network and figuring out the best way to route everything. Spanning tree is kind of like OSPF, but it's for layer 2. It will learn which switches are connected where. It'll figure out the cost of each path, all that kind of stuff. Originally, it was designed for detecting loops in networks. So if you got two switches and plugged them both into each other, you didn't get the whole broadcast storm like you normally would. It would say, oh, this switch is available on both ports. Let's turn one of these ports off, and then we avoid that routing loop. Now, one of the side effects of that is that you can get a giant switch network, plug it all in together, turn spanning tree on, let it figure out the topology of the network, and everything will just sort of figure out the best way. It'll use, say if you've got GigE and FASTE, it will use the GigE links and preference, all that kind of stuff. Linux supports Ethernet about as well as anything else on the internet, apart from Microsoft. It has the capability of creating what is known as an Ethernet bridge, which is basically a switch. So if you have a Linux box with 4 network ports, you can essentially make a switch out of those ports using the bridge module. It's actually a really good system. It supports spanning tree natively, so you don't have to mess around with any user space junk. It's all in the kernel, and it's really simple to set up. Most Linux distros these days, like I know Fedora does, Red Hat, Debian, Mandrake, they let you set up bridges and stuff like that really easily within their configuration files. You don't have to go through and hack stuff by hand, which I'm sure some people will be disappointed. You can still hack it by hand if you want to, but you can obviously set it up so that at boot time it does spanning tree. Linux also supports Ethernet bonding using I think it's if nslave or something like that is the kernel, the command line tool for it. Basically, if you have two NICs in a box, it will withstand one NIC failing, but it won't, since they both have to go into the same switch, it won't cope with the switch failing. So you kind of have to weigh up, do I want extra bandwidth versus do I want extra redundancy? You can get gig Ethernet cards now pretty cheap, so is it really worth getting 2 gigabits per second versus actually having the thing up all of the time? Spanning tree is great simply because it's really, really quick at rebuilding the topology on the network. Essentially, the way it works is that all the switches talk to each other using spanning tree. They figure out which one is what they call the root bridge, based upon a cost that you can give each bridge, and a priority for a cost for the port and a priority for the bridge. So you would say if you have, say, core gigabit switches, then they would have a higher priority than any sort of fast Ethernet switches. All these switches will learn from each other, how to get to different networks. They will learn a topology of the network in terms of, if I want to go here, I've got these 2 ports, but this one is shut down. So it works very well. If you use regular spanning tree, you can literally just unplug the power plug from a switch, and everything will just refigure out where it's going. It takes about 10 seconds for that to happen. So if you work within your 5 nines thing, you can do that about 30 times a year. So if you need to upgrade the firmware or something like that, you can do that. There's also an alternate to spanning tree called rapid spanning tree. I think it's 802.1w, which gives you really, really fast failover. Basically, the way it works is that rather than actually blocking a port, it'll just shut down any non-broadcast frames on it. So you'll still maintain spanning tree sessions between all ports, even if they're shut down. So you can actually do that in less than 5 seconds. It usually averages around 3 to 4. So it gives you a lot more flexibility. With obviously connected to a Linux box, it gives you the advantage that when you unplug a switch, the Linux box will automatically figure out which one to go out. Linux right now, I believe, does not support rapid spanning tree, but you can use both rapid spanning tree and regular spanning tree on the same network. And a Linux system will just go and it'll do the spanning tree exchange. It'll see what's on the network and it'll just shut one of the ports down. If the other port becomes unavailable, then it will just start sending traffic to the other one. So this is all stuff you can tune. If you're really insane, you can make spanning tree send packets out every second for updates, and then set the dead time on it to 5 seconds, and it will still work. But it's worth bearing in mind that the lower the dead time is, the more impact small changes would have on it. So if you have to just move a cable, then you have to make sure you do it really quick. That's an example of setting up a bridge in Linux using ETH1 and ETH0 as ports. Pretty boring. But it lets you plug one box.
It works on the WRT too.
It does?
Yeah.
Excellent.
And everything.
Everything.
VLANs too.
Cool. So yeah, this is the simple way to get a Linux box with 2 NICs, plug it into a couple of switches, get some redundancy. So any questions at this point? Yes?
The recommendation on how powerful the machine can be?
Depends what you're doing with it. 10100 network, I would probably want a Pentium. The main consideration is the speed of your bus on the motherboard. So something that's running at 100 or 133 megahertz is probably a better choice than something that's running at 33. Until you start using gigabit Ethernet, anything greater than a Pentium 200 is probably fine. I think probably low-end Pentium 2 can easily handle 100 meg of traffic. Obviously, bridging, you can handle more traffic through a bridge. than you can with a router. But you can still, if you're just doing basic routing, a Pentium 200 is still going to do pretty well. Once you start getting into more complex networking configurations, say if you're doing NAT on it, once you start NATing 100 meg of traffic, you start using a lot of memory and a lot of CPU just for that. So, it really depends upon the type of traffic that you have. Even on a 10100 network, you're probably not doing 10100 out to the internet. You've probably got like a couple of T1s, if that. So, or a cable or DSL or whatever else. So you're still limited at some point to a small pipe. So you really don't need anything too extravagant. Depending what else you're doing with the router, if you're going to run any routing protocols on it, if you're going to run anything like IPsec or any VPN stuff, that needs a little bit more horsepower. But in reality, unless you have a really complicated network, something pretty simple is going to cut it. Of course, the one thing to bear in mind with any router, if it's an old box, you want to make sure it's going to run solid. You want to make sure the power supply is good, make sure the memory's good, because as soon as you have a flaky router, people know about it. So you kind of have to make sure you're okay there. But you really don't need a whole lot of horsepower for any of this stuff. It's all pretty basic. Anything else before we move on? Nope. Okay. Okay, everybody knows what IP is in terms of networking. It's what is referred to as a routed protocol. Protocols like IPX are not routed in that they all exist inside one network. So IP, you can actually route between separate Ethernet segments. And to do that, you use a router. So a router is essentially a IP switch. So you can think of a switch as being a Ethernet router. It will route Ethernet frames out of a port. A router will route IP packets out of an interface. So I like to differentiate my layer 2 and layer 3 stuff by saying layer 2 has ports, layer 3 has interfaces. So it may be the same thing physically, but it just makes more sense to do it that way. So you have an Ethernet port at layer 2 and an Ethernet interface at layer 3. And obviously then at layer 1 you actually have an Ethernet hole to plug stuff into. So a router will provide routing capabilities between physical separate Ethernet segments or VLANs within a network. So if you have a network and you chop it up into different little networks using VLANs, then you use the router to route between all of them. Within this, there's a routing table that basically it's like a little index to say, if I want to get to this box, send it out this interface. Want to go to this one, send it out this interface. Pretty basic stuff. Because it is a routed protocol, we can use a routing protocol to distribute the route information between multiple systems. The main two that are used on systems these days are OSPF, which stands for Open Shortest Path First, which is a protocol used inside a network. To talk between networks, you use a system called BGP. Anybody who has ever worked with an ISP or done anything more extravagant than cable modems will know that BGP is very, very complicated. It's one of those things that you go through a couple of weeks not understanding it, then it kind of clicks in your head how it all works. So BGP is something that is pretty complex to understand, and it's certainly, I wouldn't say it's outside the realms of a normal person's knowledge, but it's something that if you're going to use it, take the time to figure it out before you start messing with it, because once you start messing with BGP and you start having route flaps and all this kind of stuff, then you can really get yourself into some trouble. Like I said, OSPF used inside a network. Basically, if you have two routers, each with various routes on them, they will talk OSPF between the two of them and distribute all of the routes between them. So I don't have to go, if I have a network of 20 routers, I can add a route to one and all the rest just learn it from that. So it's really, really simple for setting up a network. The great thing about OSPF is that you can have multiple paths to one particular route. So if one router fails, it will just use an alternate path to get to that route. Now, compared to a protocol known as RIP that existed it still exists, but nobody uses it. RIP would actually be a protocol that would go out and basically every 30 seconds say, okay, what are the routes? What are the routes? OSPF works completely differently in that it's based upon the state of a link between two systems. So rather than actually having a real dead time like RIP does, OSPF can failover routes a lot quicker. RIP initially would wait like 90 seconds before it would take a route out. And 90 seconds is a lifetime if something's broken. So OSPF, usually within 10, 20 seconds, it will kick over and use an alternate route. So this is a great way to handle lots of networks attached. Say if you've got a building, each floor has a separate network, you want to each one has its own router, then you're pretty much good to go with OSPF. Now BGP is used to distribute large aggregated routes between different subnets or different organizations. BGP, rather than being a broadcast network like OSPF, you actually have what they call a peering session. So say if you go and get a T1, DS3 or something from a ISP, then they will supply you with BGP information, so you can talk BGP to them. You will receive routes from them, and then you will advertise routes on your network to them, so obviously people on the internet can get to you. BGP basically is what makes the internet work. Everybody talks to everybody else via BGP. Every network, or at least most networks above a certain size, have what's known as an AS number that defines it on the internet. So that's all set up like that. Now, right now there are about 150,000 routes distributed via BGP, which is just sick and wrong, because people distribute little tiny /24 networks, like 16 of them all at once, which is just stupid. So probably once it hits 200,000, something's probably going to break, because people with routers will just be like, my router's got no memory. What do I do? Especially if it's Cisco. Now back to Linux. We can do OSPF, RIP, BGP for both IPv4 and IPv6 using a little tool called Quagga. It's actually a fork of a project called Zebra that existed a couple of years ago, and it kind of stagnated for a while. So I believe a Quagga is like a little tiny Zebra thing, like a goat or something. I don't know, but it does all the same stuff Zebra does, but it actually is maintained. You can make Quagga talk to Cisco, Juniper, Foundry, whatever else stuff. So it's pretty flexible. I've done peers with Quagga and Zebra to Cisco routers, all that kind of thing. One of the neat things is with Linux, you can get cards that will do T1 and DS3. So if you want to actually be crazy, you can go to a large ISP like Global Crossing or Level 3 or whatever, or Antinet, right, Greg? And say, we want a DS3 and plug it into a Linux box. And then you just do all the BGP over that. So you don't need all those stupid expensive Cisco routers. You can use Linux. Now, obviously, in terms of high availability, it's not just the routes that we want to maintain, but it's also the IP addresses. So there are sort of two different ways that this works. There is the process of IP address migration, where essentially one system will notice another one dies and steals its IP address. Now, this can, obviously, you can just go to a box and do ifconfig eth1 down, ifconfig eth1 : 0, add another IP address. If you ever do that, you'll notice that it just doesn't work, because everything else on the network tries to send the traffic back to the MAC address of the dead box. So what you have to do is force an ARP update across the network to make sure that everybody gets their ARP cache flushed out and all that kind of stuff. Now, the way this is done is different for every single platform out there. There's kind of a standard, but there isn't. Cisco uses a system called Hot Standby Router Protocol, or HSRP. A lot of other systems use a system called VRRP, Virtual Redundant Router Protocol. OpenBSD uses something called CARP, which is similar to what we're talking about today, but it's different. There's also a version of CARP for Linux, which I don't know how well it has been developed at this point. Never used it. Linux uses a system called Heartbeat, which is just completely different to everything else. So it's it's a completely different kind of crap. There is a VRRP service for Linux, but I don't know why anybody would use VRRP anyway, since Heartbeat will do a million more things. Now, the actual Heartbeat process uses 2 Linux boxes. Obviously, they have a heartbeat between each other to maintain state. So you can either use Ethernet or serial. Obviously, Ethernet not quite so good, since if the switch dies, then you're screwed. Serial is always good because you can just do null modem cable between the two, and you actually know when the system fails. With Heartbeat, you can either have a active-passive configuration where all of the resources exist on one box, and when it dies, they migrate to the second box, or you can have an active-active configuration where you have certain resources available on the 2 systems. When one dies, its resources move to the other one. When it comes back up, those resources move back to this. So depending upon how complicated your network is and what you want to do with it, different configurations work equally well. Heartbeat is really great because once you get the base configuration working, the configuration is a list of IP addresses. It is so simple to set up that an MCSE could do it. I mean, it's really simple. It also lets you do some weird stuff with networks, like you can assign IP addresses to blocks that shouldn't have that IP on. It's really flexible. You just as a resource, you can have a floating IP address as a resource. Most systems, you have to have IP on this, and a floating IP in the same subnet. With Heartbeat, you can just pull an IP out of thin air, slap it on the network, opt for it, and you're done. It also works with network services. So if you're, say, running a network monitoring tool on a box, you only want it up on one box at a time. When a box fails, it'll obviously be shut down. It'll bring it up on the second box. So you can actually start and stop things as you go. One of the good things about this is if you're running any redundant disk systems like DRDB, which I'm not talking about that in this presentation. It's a little bit too complicated. But basically, it will let you mount. Also, if you're using, say, something simple like iSCSI, where you can mount the disks multiple times. Start and stop. Stop is mount it read-only. Start is mount it read-write. Pretty simple stuff. So if you're using any SAN architecture or any kind of clustering stuff like that, then you can include that in Heartbeat. Now, the actual failover process is fairly simple. Basically, 2 boxes will send packets to each other. One, basically, like it's a hello every 2 seconds. Hello, hello. Yep, I'm still alive, blah, blah, blah. As soon as it starts experiencing a level of packet loss, say, for example, in 20 seconds, it only sees 2 packets. It'll indicate that it's failing. So the system that sees that will then try and ping the other system, or it'll try and send it a heartbeat signal, like a "Are you alive?" heartbeat. If it doesn't get anything back, then it's going to assume it's dead and go through its whole failover process. On some networks, you can use a system called shoot the other node in the head, which is basically a system where if you don't ping it back, you just go and you use a serial port into a power switch and just turn it off. So I mean, it just kills it. And then obviously at that point, the resource takeover starts over, starts assigning IP addresses, starts ARPing for stuff, blah, 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 whatever services are going to come up. There's a tool called Fake, which is what Heartbeat uses to send a ARP request to force everybody to update. So it's pretty useful. There are some other tools that can do that, but this one seems to work pretty well. The shoot the other node in the head thing that Greg was laughing about is to avoid what is known as a split brain. Now, if you imagine a system where you have 2 nodes on a network and they're heartbeating back and forth, and that heartbeat fails. Say, for example, somebody unplugs a serial cable. You then have 2 systems which are trying to heartbeat each other, and they can't talk. So they both think they're the active node, or that they're the primary node. So they both start bringing up IP addresses and ARPing for stuff. And sometimes, that's not really the end of the world, but it's never good. And especially if you're using something which is actually having a persistent connection like NFS, it's really going to break things. So using the shoot the other node in the head process really makes sure the other node is dead and it isn't just the heartbeat link that's failed. Obviously, what you really want to do is have a heartbeat link that isn't going to fail. So you can use Ethernet, you can use serial, you can use both at the same time. You can also increase the dead time for a node. Say, for example, you might have a situation where on a Ethernet network you start getting a massive broadcast storm and then it stops. Now you want to make sure that within that, say if you have a packet loss period in there, that it's not going to kill everything. Now, what you really want to do is have the heartbeat on a dedicated either crossover cable or on a separated VLAN or on its own switch or on its own pair of switches connected using bridges, whatever's going to make it work. Now, before we move on to layer 4, any questions? Nope. Okay. Layer 4 is the layer that exists in terms of transport. Is it transport? Yes. Yes, it is. So it's where stuff like TCP, UDP live. All of the ports used by common protocols. So you've got, I just listed a bunch of stuff up there that I could think of. That pretty much covers everything that people use all the time. Probably POP3, IMAP in there maybe. I don't know, some other crap too. Within a HA network, what you would generally do is rather than actually assigning addresses for services, you would have an address that a gateway box has, and then you would just use NAT onto a non-routable address. So you can really just move that. Is that me? Okay. You can use NAT just to move that around. So say if you have two boxes, 10.1.1.2, 10.1.1.3, and you have a gateway box, and you say, I feel like I'm going to run my website off 10.1.1.3 instead. You just go and change the NAT rule, and it moves over. You don't have to wait for any stupid DNS updates. It's done like that. Any existing connections on 10.1.1.2 will just wait and will be served by that box until it times out, and then it will be moved to the next box. So that makes it really easy to move things back and forth. Linux has a system called IPVS, which stands for IP Virtual Server, which is basically just what I talked about. It's a system where you have one IP address and some other system behind the scenes. IPVS includes load balancing capabilities, so you can have like 10 boxes back there all doing SMTP or HTTP that distributes the load over. This is what FARC needs. I mean, it's basically a system that will distribute traffic between multiple boxes. And it works really well, and it can be included as part of a HA architecture. Obviously, the IP addresses used by IPVS would migrate from one system to another, and then the backend boxes, when one fails, it would get taken out of the IPVS list. It's all pretty basic stuff. There's tons of documentation on IPVS on the internet, and it just works really well. IPVS uses IPVS module in the kernel, and it's now included in Linux 2.6 as part of NetFilter. It will do everything for us, so we can supply an external address for the outside address and an internal address for the internal address, and it will figure out all of that for us and all that kind of fun stuff. So you basically just plop it in there and it works. It uses a little tool called IPVS admin that is kind of similar to IP tables, but not quite the same. And it just lets you do basic stuff like add systems, take them out, look at the status, all that kind of stuff. You can also automate that using a tool called Mon, which will go out and try and connect to the boxes or whatever, take them out of IPVS, and off you go. Obviously, in any kind of load balancing configuration, you can say, okay, this box I want to get twice as many connections, this one 4 times as many. So you can weigh the connections pretty easily. There's probably some way to do that dynamically in terms of you could do an SNMP lookup at the load of the box, figure out how high it is, and then change its weighting, but who cares? So this is kind of what you end up with in terms of IPVS. So you've got your little old user over there trying to get to the boobies link on FARC, and then the big evil internet. At the front you have two boxes running Heartbeat, which in Linux, or in terms of IPVS, are called local directors. You have a primary and a backup, and then you have what are called real servers behind it, which are actually running Apache or something. So you have your real servers back there serving out the traffic. If the top director dies, then you can just move everything to the second one, and it just keeps working. One of the boxes behind there dies, just keeps working. Want to add another real server? Add it in, add it to the list, off you go. Want to take one of those boxes out to kick it, take it out, kick it, put it back, and it's just working. So all of that stuff is completely automated. It just works really well. Now I was really bored, so I thought, I got a firewall that really sucks. I want to make it do HA. I want to make it do crazy stuff. So I went and basically built what I thought was a firewall architecture that wouldn't break. So I got myself a couple of little 1U boxes that probably cost like $500, and they run Heartbeat and OSPF. So they heartbeat between each other, and they distribute internal routes between each other using OSPF. Got a couple of Netgear switches, which are like $150 now that do management. So they include STP. I did gigabit Ethernet just because I could. And most boxes behind the scenes have multiple fast D connections, so I can take a switch out and everything will just keep working. So far, 100% working. Rebooted switches, done kernel updates and everything. Some retard behind there got DOS because I guess they posted something on some forum that people didn't like, and it just went, like 120,000 packets per second of UDP traffic. It just didn't care. And it was actually natting this stuff at the same time. So, Linux is a really good system for doing this kind of stuff. Obviously, you can't compare that to, say, a Cisco router that every time it sees one of these 120,000 packets per second, it has to do this massive lookup in its rib of all of the 150,000 BGP routes, and it goes, oh, every time. So, it's not an equal comparison to Cisco stuff, but if you wanted to load BGP onto Linux and then do the same tests, then you could see what happens. Essentially, that's what it looks like. It's kind of ugly, but it's tidy. Now, this is basically what it cost. Cheap. Netgear switches are cheap. So FSM 726S. We found a website on the internet that sold these things for $150, and they're refurbs, but they work really well. They give you 24 fast E ports, 2 gig ports. So you can either do gig Ethernet or gig Ethernet over copper or gig fiber using GBICs, and they basically just work really well. You can do VLANs, STP. It'll let you set up a bunch of different stuff. You can SNMP them. They're basically great for little distribution switches. Probably don't want to run them on a big network as a core, simply because they don't really have enough backplane speed to handle a lot of stuff. Netgear do have some gigabit gear that I like, that gives you like 2410, 100, 1000 ports. Linux boxes, they're basically just Pentium 4 3.06 gigahertz Pentium 4s with a gig of memory and 3 disks in RAID 5 using software RAID. So they cost about $600. They're not going to break the bank. Gigabit Ethernet fiber cards, Netgear GA620s. That is not an error. They were 99 cents on eBay, and I got 5 of them. So I got lots of spares. I think the shipping was like $6. But yeah, they were cheap as hell. So you can pick up this stuff really cheap. Now the one problem we did have is that the drivers that those cards use, it's called ASNIC driver. In the kernel, it doesn't do hardware checksumming, which is kind of crappy. However, one of the problems with this was that in one of the kernels, somebody decided, I'm not going to clear that when I have a fragmented packet. So it just basically broke the whole thing. So I went for about 2 weeks trying to figure this out, and eventually got a patch together that fixed it. Now it did. I mean, I literally had all the time in the world to get this thing up and running. And it did take me 2 weeks to make it all work, simply because I was poking at it all the time like a lunatic. But it is actually up and running in production now. It works really well. So this is something that you really need to understand it before you implement it. Put it on a test network with the identical amount of stuff, identical traffic. Like actually sit it right next to the production network and have it running there. Because one of the issues I had was I could only replicate it with a fragmented UDP packet coming from somebody in Korea, and I didn't get them very often. So it took literally just a week just to figure out what the packet was that made it break. Then it took another week to figure out how to fix it. Now, the interesting thing was, once I figured out what the packet was, I got a patch from the Linux kernel people in like 20 minutes that fixed it, which is scary. So, for those people out there who have problems with their Cisco gear or their Microsoft stuff, I mean, it just, the Linux community is just really good at fixing stuff. So it ended up being a pretty serious problem in terms of fragmentation of packets. That I think it ended up in 2.6.11 or something. So pretty useful, pretty interesting process of learning, because I know a lot more about all of the low-level stuff in the kernel now than I used to. So I can usually debug stuff pretty well. Okay, what was learned by this whole building process? Never assume the Linux stuff works, because it probably won't. Especially with older cards, like anything more than a year old, it's probably not even maintained anymore. There's a lot of stagnated drivers out there. So you want to test them really well. Test it under load, like throw a whole load of traffic over it. I mean, don't just ping flood the thing. Actually, set up FTP, do some transfers, TFTP, do some UDP stuff, all that kind of thing. Cheap hardware has its benefits. If you can spend $4,000 on a big ass server, or you can spend $4,000 on 10 really little ones that if they break, you just go, okay, I'm still running. I mean, it's a lot different. So it's a different sort of way of looking at network provisioning. I wouldn't say go out and buy little tower boxes that cost $250 and use them as web servers. You still do have to have some, realistic bounds. But certainly what you can do is get smaller boxes, get lots of them, and when they break, you can actually just replace them. If you spend $5-6 on a box, even if you have 4-hour turnaround on parts, that's still 4 hours of downtime if it breaks. 4 hours of downtime till you get the part to fix whatever broke. So you may still have another 10 hours of whatever to get it working really well. So recovering from backups, blah blah blah. So if you have a configuration that just recovers well from failures, then you can work around that. Micro Center. Anybody here shop at Micro Center? Anybody here bought something from Micro Center and it not worked? Anybody here bought something from Micro Center, returned it, and then bought the same thing again? That's what we think they do, but they probably do. Basically, I've bought probably 6 motherboards from Newegg on the internet. They all work. I bought 3 motherboards from Micro Center. None of them work. So, I think something funky is going on with Micro Center. So basically, don't buy stuff from Micro Center. Don't buy motherboards. Other stuff works. Like hard drives, I've only had to RMA 2 of them so far out of 7. So I'm doing pretty well. But yeah, unless it's in a sealed box with the original tag on it. But especially that clearance table. It's on clearance for a reason. Okay, last night I had a disk die on me, which was really great because I could actually demonstrate failover. So as you can see, about 2:30, something went completely apeshit on me. And the first box decided it was going to die. The great thing is the second box said, it's dead. I'm going to handle all its traffic. So as you can see, all the traffic moved from one box to the other. It's kind of difficult to tell simply because the graphs aren't the same. This top graph, the top part's 10 meg, the bottom graph, the top part's about 6.5 meg. So it's the graph scaling's off. But certainly, I mean, it was literally like that. There's probably less than 10 seconds of downtime. So everything still kept working. I didn't know it was broken until I came in this morning and tried to SSH into the box, and it wasn't there. So it does have some advantages. So hey, you know your stuff works really well when you don't even know it's broken. So
that's what Microsoft says.
Brokenness is an illusion. So you can just migrate traffic back and forth. And this runs a whole ton of different things. It actually has some voice over IP stuff behind it that I use from home. And I used voice over IP this morning, and it just still worked. And I didn't even know this stuff was down. So you can do a lot of weird things with it, and it's obviously pretty flexible.
Do you have no cloth behind that?
Yes. That's what
The next time we get slashed out, it'll be able to handle it.
I will. Can you read it? You're like, I don't know. Obviously, the one advantage of this is that if you have multiple services, say for example, like the top box that died was running a DNS server. Well, because it was actually running through NAT on itself, when the second one came up, it assumed the IP address of that DNS server. So the DNS stuff still works, even though it's running on a completely different box. So it's all pretty flexible in the way it works. Once you start playing with NAT on Linux, the whole concept of this service runs on this box is just thrown out the window. It's this service runs on this IP address, which is NATed to the internet on this IP address that people see. So you can just move stuff around all over the place and nobody notices. So there's a lot of flexibility there. And obviously, 2:30 in the morning, am I going to get out of bed to fix a router? No. So the fact that it still works is obviously a good thing. And everything behind it kept on working. So this wasn't planned, by the way. This just actually happened out of damned unluckiness, or whatever the word is. Something hates me, so yeah. So that's my contact info. If anybody wants to take notes, anybody cares. Websites. Linux-ha.org has lots of stuff on Heartbeat, lots of stuff on using Linux for HA stuff, using DRDB, all that kind of good stuff. LinuxVirtualServer.org is where IPVS lives. If you want to set that up on a network, then lots of things there. And then there's LARTC.org, Linux Advanced Routing and Traffic Control How-To. It's basically just this giant documentation that tells you how to use all the crazy networking stuff in Linux that nobody else documents. So there's a tool called IPRoute2 that if you use Linux and haven't got it, you should probably get it. It will let you do everything to the Linux kernel that you want in terms of networking. It will do all of the crazy routing stuff. It will let you route based on source port. I mean, it will do stupid stuff like that. So if you want to route all of your outbound IRC traffic via a dial-up, you can. I mean, it's pretty useful. I actually use it to do traffic prioritization on a DSL and a cable modem. So all my voice over IP traffic goes via the DSL modem because it's only like 20 milliseconds away from the VoIP gateway. All of my heavy traffic, like FTP, HTTP, all that kind of junk, BitTorrent, goes out the cable modem, and it works really well. In general, the LARTC site is a really, really good resource for Linux because it will explain how to do a lot of the stuff that you could normally only do with high-end Cisco gear, high-end Foundry Juniper stuff, like policy-based routing. It'll explain to you how to do that on Linux. So if you want to really mess with Linux and do some crazy networking stuff, print that thing out. It's probably like 90 pages, but it's a good resource to know about. So. Yes?
I think you should talk a little bit about UltraMonkey.
That's just all of the...
It makes it easy to set it up. And that's the point.
Yeah.
Just throw the RPMs on top of a Red Hat or
the
distribution.
There are a couple of tools that can be used to build HA stuff. One that Greg mentioned is called UltraMonkey, which is basically a combination of Heartbeat, is it Mon, IPVS, has it got Mon in it too?
I think so.
Yeah. The guy from VA built that.
I wonder it works.
Yeah. That's what Slashdot uses now. Basically, it's all of this stuff combined in one package that you just install the RPMs for. Now, the one thing to bear in mind is that most Linux distributions do this stuff out of the box, but they won't help you to configure it a whole lot. Debian is actually really good. You can do apt-get install Heartbeat, apt-get install IPVS, apt-get install bridge utils, and it will just install the whole lot. It won't set it up for you, but it has really, really, really well documented configuration files. So I'm running all my stuff on Debian just because I'm like that, but it just works. There is actually a distribution. There was a distribution from Turbo Linux Cluster Server. I think Turbo Linux went the way of like 99% of the companies in 2000, in that they burned through all of their VC pretty quick. But there are a couple of distributions that are designed for clustering. I know there's a couple of live CDs that are designed for clustering. So part of the advantage of HA is that once you get your provisioning set up, say for example, I need a new mail server, you stick a CD in it and it works. Or you note the MAC address and you put the MAC address in your boot P configuration, and it will just do like a kickstart install from the network, install a mail server on it. So you can do a lot of funky stuff once you get the basics up and running. Certainly you can go to some lengths to actually make this thing pretty complicated. So for example, if you have a box sitting there doing nothing, and all of a sudden we're getting slammed with web traffic, we need a new web server. Okay, here you go, plug it in, add it to the network, and it just starts handling web traffic. So it's a really flexible system, and it gives you lots of opportunities for doing lots of things. Obviously with Linux, you can do probably 99% of that on anything. You don't really need a lot of hardware for it. For routers, like I said, the main issue is bus speed. You can do 100 meg over probably a 66 megahertz bus. Once you start looking at gigabit stuff, you really need to look at 64-bit things, 64-bit cards, not things, simply because the gigabit cards handle so many interrupts. SIM cards will interrupt once for each packet that comes in, which will just completely kill the whole box. A lot of the newer cards will actually only interrupt for certain amounts of packets. So you get a little bit of latency in there, maybe like 1 or 2 milliseconds, but it does reduce the amount of interrupting you will see on your PCI bus. Obviously, you get some higher end gear like you get from HP and things with, 66 megahertz, 64-bit stuff with like 64-bit NICs. Then you can stick a whole bunch of gigabit stuff into one box and it will work happily. In terms of the hardware, I've had good success with the Netgear gig cards. They have a GA620, which is the cheap one. There's a GA621, which costs about $50 on eBay. I know Intel have a lot of good copper and fiber gigabit cards that come in useful. I think Intel have a dual port gigabit PCI card, which is pretty cool. So get those on eBay for about $50. So eBay is a great resource for this kind of thing because people have no clue what the hell it is. They don't know what to do with it. So you can get it cheap. So, well, I guess now people know what to do with it and it won't be cheap, but when I built it, it was cheap. So it's kind of, you can do lots of different stuff. Any other questions? Anything? Last chance. I'm done then. Well, thank you for coming.